So remember in the first two sections for chapter 4, we introduced the exponential functions in 4.1, and then we talked about logarithmic functions, which are actually the inverse functions for exponential functions in section 4.2. So again, just keep in mind, both exponential and logarithmic functions are inverses of each other. We looked at their graphs, did a little comparison. Excuse me. Now we're actually getting a little bit more detailed into rules of logarithms. If you guys will remember from our discussion last time, if we were trying to solve an exponential equation, we were converting it into a logarithmic equation because sometimes that was easier to find the solution. Or we were taking a logarithmic equation, of course, turning it into an exponential equation to solve it. So now we're actually getting into rules of logarithms to help us maybe simplify some of these logarithmic functions a little bit better and see how we can simplify and solve them. So we have these rules of logarithms, which you will see will correspond to rules of exponential functions. If you remember, for exponential functions, we have the product rule, where the idea is if you are multiplying two numbers that have the same base. So you can see we are multiplying 2 to the third with 2 to the second power. So when they have the same base, the rule is you keep the base as it is, and then you end up adding your exponents together. So 3 plus 2 gives us 5. So that's your rule of exponential functions. When we convert that into the product rule for logarithms, it basically comes out, and you can kind of see how they're trying to show you here the correspondence between 2 to the third would be equivalent to log of 8 with base 2, to the second would be log of 4 with base 2, 2 to the fifth would be log of 32 with base 2. So what they're doing is they're taking this log of 32 and they're breaking it down into 8 times 4, and you can actually use addition to break down a logarithm over a product. So basically the idea is you're multiplying 8 times 4. So the rule of logarithms breaks it up into log of 8 with base 2 plus log of 4 with base 2. So, of course, you're keeping that same base 2 over here. You're breaking down your 32 into 8 times 4, and that's where this log of 8 and log of 4 is coming from. So for your product rule, basically the idea is if you have a product inside a single logarithm, you can break it up into these two logs, multiple logs, by using the addition symbol. So you will see we're talking about the logarithm of a product of two numbers is equal to the sum of their logarithm. So the product of two numbers is going to be equal to the sum of those two numbers. And then, you've got some examples in here to kind of help you walk through that. So you can use this rule in two ways. You can either take a logarithm that's already broken up into multiple logs and convert it into a single logarithm. And for this to happen, of course, we want to make sure our base is going to be the same on all the logs before you can combine them into a single logarithm. Or we can take a single log and, break it up into multiple different logarithms. So you can kind of go in both directions with these rules. So let's take a look at our first example here. Yeah, and looks like it's going to be a little bit of a slow going over here.
Yeah, mine just completely kicked me out again.
Oh, it did? Okay.
Yeah, I was thinking I had two windows open and I don't. It's got some issues.
Same here.
Yeah, and that's kind of what I was afraid of when all of you started sending me messages about how it was slow loading your page, but really working slow. Yeah, it's not looking very... I'm actually gonna see if it will let me. I know some of you had told me you were also having trouble opening, I think, the textbook. Okay, Betsy's still working slow. Yeah, that seems to be it because my page, it's showing that it moved to the next problem because I was on 136, but my page did not change over here. So there's definitely something going on with the server at my math lab. Since our textbook page is not going to load either, I'm actually going to physically bring my textbook out. And I'll pick some examples from the textbook for us to work on. Okay, let's take a look over here. Megan, you got a system error notification. So yeah, it looks like their server is struggling. And one of the things that actually happens right about this time is, this is a busy class time. So a lot of people are logged in also, and that puts stress on the system also. So yeah, I think that's kind of what we're running into. Okay, so what I am going to do is give you guys an example over here and we'll work through that. Okay, so this is actually from your textbook. And I'm looking at number 14 here, just to kind of give you an idea of how we can combine two different logarithms into a single logarithm. Okay. So the instructions are basically rewrite each expression as a single logarithm. So as I said, when we're working with these rules, especially if you're taking two different logarithms and you're going to be combining them by using, product rule, quotient rule, any of those rules, always start by verifying that both your logarithms have the same base, because these rules will not work if you have base 3 on one logarithm and base 5 on the other one. So always make sure you're looking at the same base before you start combining them. So the plus sign actually tells us that we will be using the product rule over here for of course logarithm. So we'll be using the product rule, which basically tells us if you have the plus sign, keep that log with base 3 the same. But then what we are going to end up doing is remember it's addition with multiplication. So that means you are taking both of these values in the parentheses and you will be multiplying them together. So we are taking our expression of x plus 2 and multiplying it with x minus 1. And let me show you that rule here again. So you're basically looking at the right hand side. This is what's given to us, log of x plus 2 and log of x minus 1. So keeping the same base, we are multiplying these two expressions, and that's what's happening over here. So that's exactly what we're doing. So what's going to happen inside the parentheses, since these are two binomial terms, remember for these kind of terms, we will have to use FOIL to try and simplify this. So what do you think this will come out to be when we multiply our two terms over here? Yeah, very nice, Jess. So this will end up giving us x squared when you do the first two terms. This would be negative x, positive 2x, and then of course minus 2. Combine these guys together into just 1x. So you get x squared plus x minus 2. So yeah, good job, Jess. And so that will be your answer. And like I said, that log with the base 3, you know, of course, will carry forward. So now this becomes log of x squared plus x minus 2 with base 3. And, you know, if they had given us this as the original expression, then, you know, of course, we would be going backwards by using factoring. Now let's take a look at slightly different example here. How about we take a single logarithm and try and break it up into multiple logs? I'm trying to see what I like here. How about this guy? So we are given log of a squared minus 9, and they want us to break it up into multiple different logarithms. So remember, when you have no base, like this guy here, you're just given log of a squared minus 9. What base do we understand that to be?
10.
10.
Very good, nice. Yeah, good job, guys, because that's your common log. It's understood to be base 10. Yeah, Alice, very good. So now think about it. We're kind of looking at, you know, the reverse from the first example. So how can we break this apart into two different factors, our a squared minus 9? So that's the first step you will need to start out with, is how are you going to factor a squared minus 9?
A minus 3, a plus 3.
Very good. Yeah, use difference of squares over here, because we can write 9 as 3 squared. So this is your a squared minus b squared format, which factors into a plus b and a minus b. So that will translate for us as a plus 3 and a minus 3. So very nice. We'll go ahead and rewrite this guy as log of, let's do it like this, a plus 3, a minus 3. So those are our two factors now. So using the product rule, how are you going to factor this logarithm? Or, you know, basically rewrite it. So using this rule, how are we rewriting this?
Would it be log a plus 3 plus log a minus 3?
Very nice. Yeah. So that's exactly what you are doing. So think about it, you know, when we had the two factors, x plus 2, x minus 1, we separated them into two different logarithms by using that plus sign in the middle. So exactly the same thing here, log of a plus 3, and then we always use the addition symbol with multiplication or product rule, and log of a minus 3. So that will be your answer for this guy. And then, you know, of course, just
So
going in the reverse direction.
you don't have to put like log 10. You just leave it as log.
Yeah, because remember with common log, when you have log of 10, it's just written as just log. You don't have to actually
Okay.
write the base out. Yeah.
That's right. Okay.
And remember, that's the same thing that happens with your log that has base e. So if you had, remember, log of e, instead of writing it log with base e, we normally write it as natural log, so ln. So these are, remember, the two exceptions to the base. So that's your product rule. Now, in that same way, you know, just like we have the quotient rule for exponential functions. So this is basically the same thing as your multiplication rule, but, you know, with division, it changes slightly. You still have to have the same base for the two numbers you are dividing. And if you have the same base, then basically the idea is we end up subtracting our exponent. So 5 minus 2 will give us 2 to the third. So that actually translates into same thing when you are using division, we will use a minus sign. So you have log of 32 over 4. And again, of course, we're keeping that same base 2. So you will do the numerator value goes first. So you have log of 32 first. And then the denominator value goes second. So log of 4 will be the second logarithm you're going to have. So whatever is on the numerator becomes the first part of our logarithm. The denominator will become the second part. So again, you can see how that translates just into the generic quotient rule. So same thing we can do here. We can convert this into a single logarithm, or we can rewrite it into multiple different logarithms. So let's take a look at an example for our quotient rule. And let's start by writing it into a single logarithm. And how about log of x squared minus 4. And then we're having a minus sign here, and log of x minus 2. The way you will identify that this is a product rule or a quotient rule, especially when you're converting it into a single logarithm, is going to be this sign in the middle. If you have a plus sign, you use the product rule. When it's a minus sign like this guy here, you use the quotient rule. So we will need to use the quotient rule here. So remember, the first term goes on the numerator. So x squared minus 4 will go on the numerator, and then x minus 2 will go on the denominator. And guys, anytime you're working with fractions, remember we always try to simplify our fractions. So looking at just what you have inside the parentheses, x squared minus 4 divided by x minus 2, do you think we can simplify that fraction? Yeah, what can we do?
Pull out x minus 2.
Yeah, because kind of like we saw with that last example with the a squared minus 9, you can do the same thing with this x squared minus 4, because we can rewrite that 4 as 2 squared. So this guy will factor into x plus 2, x minus 2. So you can see if we rewrite that numerator into its factored form, where you have x plus 2, x minus 2, and then your denominator is also x minus 2. Like Morgan said, you can actually cancel that out, and this will simplify into just log of x plus 2. So with those fractions, even though you're working with rules of logarithms, anytime you see a fraction, see if it needs to be simplified. If it does, go ahead and simplify it.
Do you know if my math lab is particularly picky on if you put the 10 next to the log, or will it always just take both?
I think it should count it wrong. I'm not sure, because technically remember with common log, since we don't put the 10, I'm not sure if it counts it as right or not. Have you tried it before?
No, I've not. That's why I was asking.
Okay, I see. Because yeah, I think since in the notation we don't really write the 10, I think it should count it wrong if we leave the base 10 in there. So yeah, I would just leave it as log of x plus 2.
Okay, I'll just continue doing it that way then.
Yeah.
Thank you.
Yeah, no, not a problem. So this was us combining two separate logs and putting it into a single logarithm. Now let's go in the other direction and see how we can split this up from a single log into multiple logs. So let's look at this one over here. We have natural log of a plus b divided by b. So now they want us to rewrite this into a sum or a difference of logs. So again, since that's a fraction, you are looking at the quotient rule. So using this rule, how are we going to rewrite this expression here.
Log of A plus B minus log of B.
Yeah, very good. And you will see, guys, again, we are given that ln. So that's telling us we're looking at natural log. So again, guys, remember the numerator value will be our first logarithm, then the minus sign, and then natural log of the denominator value, which will be natural log of B. And that's it. That's how you are separating this into a difference of logarithms. Okay, so that is looking at your product rule and quotient rule. One of the other common rules that we use in logarithms is if you have a single base with two different exponents. In this case, we always end up multiplying the exponent. So 3 times 2 ends up giving us 6. So what happens here is essentially with the power rule for logarithms, it's converting this 2 to the third into the logarithm, which will be log of 8, with base 2. And then we're raising it to this exponent of 2. So actually what happens is because, of course, remember logarithm also gives you an exponent. So you still end up multiplying the exponents, but we kind of look at it as when you have a logarithm with an exponent, on the value inside that log, we take that number n and we bring it to the front of our logarithm, and then we end up multiplying these two numbers. So you end up with n times log of m with base a. So we're still multiplying the two exponents together, but of course using logarithms. So it comes out to be that the logarithm of a power of a number is going to be equal to that same power times the logarithm of the number. So basically, like I showed you, take that exponent that you have on your value m, bring it in front of your logarithm, and then multiply the logarithm with that exponent or with that power. So let's take a look at how we can use these rules over here. How about, let's do number 30 here. And you know what, for comparison, let me give you 2 different examples. Let's start with this guy first. So let's say we are given log of 25 with base a, and they are asking us to rewrite this in terms of log of 5 with base a. So they want us to rewrite this in terms of log of 5 with base a. So, looking at this, there's not much we can do. The only thing we can do is try and rewrite that 25. So how can we rewrite 25?
Five
Yeah,
squared.
very nice. And I love the signs that Tim does because he just, he knows I'm going to understand. So I love that. All righty, guys. So we will rewrite 25. Of course, 25 is 5 times 5. So you can rewrite it as 5 squared. So you will see just as soon as we rewrite it, we can see, oh, okay, my number is raised to an exponent. So I can use the power rule to simplify this. So with the power rule, we're basically going to take that exponent and bring it in front of our logarithm. So you end up getting 2 in the front times log of 5 with base a. And this is what they wanted. They wanted us to have the expression log of 5 with base a in there. And honestly, you don't have to have that multiplication symbol in the middle. You can just write it as log 2 times log of 5 with base a, just like that. So this is one version of, what a power rule example might look like, but I wanted to show you another type of example. It's from the same section. So they still want us to rewrite our expression with log of 5 with base A. But this time the problem is log of cube root of 5 with base A. So now we have to think about how can we rewrite that cube root, because they want us to have just log of 5. They don't want it to be log of cube root of 5. So now you have to think about how can I rewrite that cube root as an exponent? Does anybody remember that conversion?
Would you just take it to the power of 3?
So cube root of 5 will not be the same as 5 to the third, because you're saying rewriting it as this, right?
Yeah.
Yeah, so this would not be equal to cube root. So how would we change that? Instead of exponent 3, what would we need to rewrite that exponent as?
You would take it to the power of 1/3.
Yeah, very nice. And we had talked about this briefly. Remember where we had said if you had an expression of A equals M over N, that N on the bottom is actually what becomes the index of your radical. And then you can have A to the power of M on the inside, or we can also write this as cube root of A first, and then put that M outside. So what happens in our case is we don't really have a value of M. You can think of that as being, just the first power. So this would end up becoming 1/3 in your exponent. Katie, does that make sense? Yeah? All right, awesome. So yeah, that's exactly where we need to go with this problem here, guys. So we will rewrite this guy. Keep everything the same, just rewrite the number inside the parentheses from cube root of 5 to 5, raised to the power of 1/3. And then using our power rule, bring that 1/3 in the front, just like we did, with 2 over here. So that would be the same thing we'll end up doing here. And then we'll end up with 1/3 in the front, and you are left behind with log of 5 with base A. Questions on this example over here? Okay, so you've got your product rule, quotient rule, and then the power rule for logarithms. We also have these inverse rules. And we've actually talked about these without really talking about these, because we just use these with, converting these into exponential notation and then trying to find our answers. But that can actually be a lengthy process. So it's actually easier to think of them as inverse rules, and they really help us simplify the problem down. So what's happening over here is if your bases are going to be the same, they're basically essentially canceling each other out. So it's kind of like when you do compositions with, if one of the functions is the exponential function, the other one is its own inverse function. So A to the X is the inverse function for log of X with base A, or, vice versa. So whenever we do a composition between two inverse functions, remember your answer always comes out to be X. And we had looked at this same rule just with different functions back in section 2.5. So actually we're bringing that same rule over here, just using it with exponential and logarithmic functions now. So what happens in this case is basically you will see my exponential function has base A, my logarithmic function has base A. So since they are essentially both two functions with the same base, you can almost think about like they are canceling each other out and leaving us behind with that answer X from the first composition. If I reverse the order of the composition, then you can see my log has base A and my exponential function also has base A. So same thing, those two functions are essentially canceling each other out, leaving you with X, which becomes our answer. So in the logarithmic format, if these two bases are going to be the same, your answer is going to be this exponent X over here. In the exponential notation format, if you have base A here, and then your exponent also has a log with base A, those guys are canceling each other out and leaving you with this x as the answer. So you can see in both of these, in all of these examples here, this is base e. Remember, natural log is also base e. So that natural log and the base e function are canceling each other out, and you would be left with square root of y as the answer. Logarithm, just log with no base. We know this is understood to be a base 10 logarithm, which means this base 10 logarithm is going to cancel out this exponential 10 and leave you with that exponent of y plus 1 as your answer. You have base 7 here. Log also has base 7. So this answer would come out to be 999. So that's kind of how these inverse rules work out to be. So I'm going to give you guys a couple examples here, and let me see what answers you come up with. We're trying to find something that I like. Okay, how about this guy? Okay. So let me see what you think about these two over here. Okay, Jess, I've got your answer for number 6. All right. So you can see you have a base of 10, which is raised to this logarithm, log of 3x plus 1. So you're basically falling back on that same idea that when you see a log with no base, we know it's understood to be a common log, which means obviously this guy is also a base 10 logarithm. So if you have base 10 over here and your log also is base 10, then those two functions are essentially canceling each other out, leaving you with just the parentheses part, which is the 3x plus 1. So that's, one of the inverse rules that we are looking at. And then Jess, you did 2K for number 8. And then same thing over here. You can obviously see that this is a natural log ln. So we know that's understood to be a log with base e. So if you have a log with base e, and then this guy is also base e, same thing, those two functions are canceling each other out, leaving us again with that exponential value of 2k. And this rule, I really like these two rules, because you will see as we get into solving problems and looking at examples, if you run across something like this, it really helps you simplify your problems quite a bit. So these definitely come in very handy. Even the other rules do, but I definitely like these two a lot. So this is just a summary of the rules that we have looked at. So they're actually showing it to you with just any base A. So that base A could be, anything base 2, base 3, base 10, base E. So they can actually include your common log and natural log, but then they just went ahead and repeated those same rules for, log E functions, which is our, natural log, the ln function. But these two boxes are basically sharing the same rules. So look at the rule number 1. You can see you have base A on your logarithm, and base A inside the parentheses. So just imagine A is raised to the power of 1. So your rules 1 and 3 are actually the same rule that we saw over here with your inverse rules, because it's coming from this same over here. If these two bases are the same, your answer is going to be X. So you can see both our bases are A and A. Your answer is going to be 1, or it's going to be X if the number is something different. That's the same exact rule over here for the natural logs. So those are actually coming from your inverse rules. You will recognize rule number 5 as our product rule. You're multiplying m times n. So we separate them into two different logarithms by using the plus sign. You will recognize number 7 as our power rule. We take that x value, that exponent x, and bring it in front of the logarithm to give us our multiplication over here. So this is coming from the power rule. We had actually talked about rule number 2 back in section 4.2 when we introduced logarithms, because I had told you, no matter what the base of your logarithm is, if you try to take log of the number 1, your answer is always going to be 0. And the reason for this is it's coming from your rule of exponents, because if I take base A, raise it to this exponent 0, my answer always comes out to be 1. So that's the reason why natural log of 1 with any base A, or even a natural log, is always going to equal 0. So that's where rule number 2 comes from. Rule number 4 is also our inverse rules we just looked at. You've got the same base A in your exponent and your logarithm. Same base E, between E and natural log. So those are canceling each other out, giving us the value of n. So that's the second part of our inverse rule over here. You will recognize number 6 as our quotient rule. So if we're dividing log of m over n, that separates into log of m minus log of n. Rule number 8 is actually also part of quotient rule and actually rule number 2. So it's a combination of rule 2 and rule 6, because think about this. If you have log, let's keep it base A, and then we have 1 divided by n. Using our quotient rule, we could separate this into log of 1 minus log of n. And then you can see log of 1, that's rule number 2, will basically end up giving us 0 minus log of n. And you can see that's where we are getting this answer of negative log of n. So that's actually what's happening in rule 8. So you can kind of think of it as, like I said, a combination of rule 2 and rule 6. So if you can remember, these 3 rules, product rule, quotient rule, power rule, and if you can remember the 2 inverse rules, those are 5 rules. Those actually combine into these 8 rules that you are looking at on this page with, base A, or translate that to any common log or natural log bases also. So these next 2 examples over here was kind of really interesting, because now they want us to do this in terms of 2 different logarithms, log of base 2 and log of base 5. So, the idea would be we would be trying to break this down into something with 2 and 5. So let's take a look at an example similar to this one over here and try and see how we can break these guys down. How about, let's take a look at number 36 here. And this one is log of 250 base A, and they want us to break this down into log of 2 with base A and log of 5 with base A. So now you got to think about how can we break down that 250 into 2s and 5s. So I'll give you a minute to kind of see how you can break down that number. So how are you splitting up that 250?
Could it be 5 cubed and then, I don't know. Never mind. I was gonna say, and then 125 times
Yeah.
2, but I don't know.
Okay, let's take a look at that. So yeah, your 5 cubed is basically 5 times 5 times 5, which will give you 125. And then you're saying multiply that by 2. Yeah, double of 125 would be 250. I think that's good. Yeah, because we want to break this up into just 2s and 5 because they're specifically asking us to rewrite it in terms of log of 2 and log of 5. So, start at whatever you're comfortable with. Like when I look at 250, I was kind of thinking, maybe I can do 25 times 10 to start out with. Then we can break down that 25 into 5 times 5. Of course, break down the 10 into 5 times 2. So you will see, yeah, we are getting 5 to the 3rd power, and then you have a single 2 left behind. So yeah, good job, Katie. So let's go ahead and rewrite that 25 inside the parentheses as 2 times 5 to the 3rd. Alrighty. Now, which rule will be used to try and break this further down? So you have, of course, the 2 inverse rules, the product rule, quotient rule, power rule. So where would you begin? Since we're multiplying 2 times 5 to the 3rd, how can we break that down?
Would you use the product rule or no?
Yeah, that is a great place to start. So that would be rule number 5, since we are multiplying our 2 numbers over here. Very nice. Let's start with product rule. So that would be, remember, product rule would be log of 2 from the 2 over here. And then we use the plus sign with product rule and log of 5 to the 3rd. So very nice way to separate those. And then we need to break it down just once more. So what can we do? Because remember, they want this in terms of log of 5, not 5 to the 3rd. Alice, yeah, very nice. Use the power rule next. So by using the power rule, you can take that exponent of 3 and bring it in front of your logarithm. Now remember, it goes in front of its own log. So when you use the power rule, this 3 will be coming in front of its own logarithm. So with power rule, our log of 2 will stay untouched. It will stay as it is. But then when we bring that 3 to the front, this becomes 3 times log of 5. So you can see this is now in terms of log of 2 and log of 5, which is what they wanted us to do. So this is how you would simplify this expression. Everybody okay on that? Did you have a question? Okay. Let me see what kind of example. how about something like this guy? So this one is natural log of 5 to the negative x over 2. And they're asking us to write this either as a sum or a difference of multiple logarithms. So they want us to basically try and see if we can break this down, with a plus or a minus sign between different logarithms. So where would we begin with this example here?
The quotient rule?
Very nice. Yeah, since you see that fraction in there. So yeah, let's start with the quotient rule. So how would we split this up with the quotient rule is? What would we write first?
ln 5 to the negative x.
Very nice. Okay, and then what would we put after that?
Minus ln to the t, or ln2.
Yeah, very good. So remember again, numerator value goes in the first logarithm and then minus the value of the denominator logarithm. Alrighty, very nice. Okay, Maggie, very good. And now, one more step. What should we do? Because we don't really want to leave that 5 with an exponent. So what can we do there?
Negative x natural log of 5.
Yeah, very good. So just like we did in the previous example, just use that power rule again to bring the negative x in front of the logarithm. Very nice. And even in the chat, I saw power rule pop up. Yeah, Emma, very nice. So again, we would take that exponent of negative x and bring it in front of its own logarithm, which would give us, as Jess said, negative x natural log of 5 minus natural log of 2. So just, basically you can kind of think of it as we're trying to clean up the logarithm, because, once we get it down to this stage, if you know what value of x you are going to be using, taking that number, we can plug this literally into our calculator and come up with an answer, if we knew, okay, this is what our x value should be. So you're basically simplifying your expression. So I'm actually going to give you one more example, and I'll give you about a couple minutes to see what each one of you come up with this. So don't send your answers till I ask you to. So let's see how we can try and simplify this into, sums and differences of multiple logarithms. So take your time. It's going to take you a little bit of, using different rules to clean this up. And like I said, don't send your answers just yet. When I ask you to, you can then send in your answer. I was trying to see if my MATLAB was doing any better, and it's still pretty slow. It doesn't look like it's improved a whole lot. So basically what you are kind of thinking of, of course, what different rules you can apply, but then also how to separate each one of those expressions. 3 has to be separate from the x squared. A and B have to be separated, with that power of 2/3. So it's going to take a combination, like I said, of different rules combined together. So, start small, start with the obvious ones, and then kind of try and break it down. Yes, Alice, they do need to be separated. Yes. So 3 needs to be separated from the x. The A and B also need to be separated. So I am sending you a link, excuse me, to a whiteboard where I have posted this problem. If you click on that link, you will see the original instructor whiteboard. So whenever you are ready to type your answer in, if you have a touch screen, you should be able to do it with your finger. If you, of course, have a stylus or a pen that you can use, on your computer, you can do that. Or, you can use your mouse to try and see. Because I want to see how you are actually writing out your answer. So I've sent that link through chat. I'll send it out one more time just to make sure everybody is getting that link. And then I want to see how you write out your answer. So I'm seeing some responses already being written out. Very nice. Take your time.
Do you want to see our whole process of solving the problem on the whiteboard or just how we write out our answers?
Write out your answer.
Okay.
And then if I don't understand something, we can talk about it. So whenever you are ready to write your answer, I'll just click on that link I sent in chat and it will take you to the whiteboard. Megan, you are almost there. Just a couple minor mistakes that I'm seeing in your answer, but for the most part, looks like you're doing pretty good. Staying on track. I'm trying to see who else has almost a completed answer. Alice, your answer also for the most part looks good. I'm just seeing a minor error in there, and I'll definitely talk about these minor errors. Eileen, again, for most part, your answer looks good. I'm just seeing again a tiny bit of a error in there. And again, for the most part, your answer also looks good. I'm just seeing a couple tiny mistakes in there. Let's see, Jess, looks like you've got your answer typed out or written out. I've got, yeah, very good. Jess, your answer looks correct. I'm trying to check and see your signs in the answers. Yeah, good job, Jess. That looks good. All righty. Okay, Cassie. Okay, again, I'm seeing a little bit of an error in your answer, but I can kind of see what you did there, why your answer looks a little bit different. And then the rest of you, if you guys are still working through, keep working. So we can kind of see what your answers come out to be. Okay, I'll give you guys about another minute to see what answers you come up with, and then we will talk about how to break a problem like this down. So Katie, you have a good start, but we definitely want to break it down a little bit more. And Maggie, looks like you're kind of on that similar track where you've started with the breakdown, but we definitely need to break it down more because even the 3 and the x on the numerator needs to be separated, and the a on the b on the bottom also needs to be separated. But that's definitely a good start that I'm seeing from you guys there. Okay. Jackie, I'm seeing something come up on your side. So a couple tiny errors that I'm seeing at your end also. So I'm actually going to come back to our notepad over here where I originally wrote out the problem. And then I'll share with you, some of the answers I was looking at on that whiteboard website. So like I said, some of you were right there, but there were some tiny errors happening, and I'll point those out. But the first thing you should notice here is, you have a fraction. You have 3x squared on the top, and AB to the power of 2/3 on the bottom. So of course, the first step to break this down would be our quotient rule. Oops. So we will first start out by using quotient rule to break this guy down. And like I said, keep it simple because we will have to break this up step by step. If you try to do too many things at one time, we're going to end up messing up the problem. So just start by quotient rule, where we separate the numerator from the denominator. So remember, this is log, a common log with base 10. So just leave it as log over here. Your numerator is 3x squared. So we separate that, bring it to the front. Quotient rule uses a minus sign. So minus, and then we will do log of our denominator, which is going to be the AB raised to the power of 2/3. So that's where we start out with. Now we will need to individually break down, the 3x squared and then the AB to the 2/3. So for this guy over here, we're obviously, multiplying 3 times x squared. So you want to go ahead and then use the product rule over here. So just by using the product rule on that first part, then it breaks up into log of 3, and product rule uses a plus sign. So that will become plus log of x squared. So this is how we actually separate the 3 and the x. Now what was happening, and I'm going to show you, your screens that I was looking at. So this is kind of what I was looking at, for your answers. I'm going to try and make this page a little bit bigger. So these are some of the answers that were coming through. I guess some of you are still working through this. And then these were the interesting type of answers because it looks like you've actually taken that exponent of 2/3 and you've actually expanded it to all the different terms in the problem. So we kind of have to be careful about, where those exponents are going and with which bases those exponents are associated with. But then you will see how some of you have actually taken this exponent of 2 that is on the x squared, but it's also being applied to our value of 3. So you will see how some of these have 2 in front of the 3x. And this is okay because, a lot of times we don't, if we don't make a mistake, we don't get to learn. So what's happening is when you are doing 2 times log of 3x, you are actually thinking that this exponent of the 2 is actually both on the 3 and the x. Because, if I were to rewrite this back, this is how this guy would come out to be if I were to go back and rewrite this, which is not what we have because your x squared, the square is only on the x. It's actually not on the 3. Because if we want it to be on both 3 and x, it has to look like what your AB looks like. You will see how AB is in parentheses and then we have that exponent of 2/3. That means that exponent 2/3 is applied to both A and the B. But look at the other side, the 3x squared. That's not in parentheses. It's not like you have 3x and then the square on the outside, right? It's 3x squared, which means the square only applies to the x term. So that's actually where a little bit of that confusion was happening. So if we just continue down this path, with the 3x squared here, so we use the product rule to separate the 3 from the x squared, and then on the x squared part of things, this is actually where you use your power rule. So it's only going to go on the x squared term, which means our log of 3 will stay as it is. And then in this guy, since we're using the power rule, the 2 will come to the front of its own logarithm. So you will actually have log of 3 plus 2 times log of x. So that's actually how this numerator part gets simplified. So you start with the quotient rule, separating the numerator from the denominator. Then we use the product rule to separate the 3 from the x squared. And then we use the power rule to bring that 2 in front of the x. And some of you obviously were able to achieve that. You have separated, I think there's Jess over here. So you can see with her answer, she has separated the log of 3 and the 2 times log of x. So that looks good. And I've seen a couple more of you do that. Yeah, right over here, Haley. Log of 3 plus 2 times log of x. That looks good. Emma, you also have that first part over there. Log of 3, 2 times log of x. Looks like Cassie, yeah, you did bring your 2/3 over to the other side. Eileen, that first part looks good. Alice, same thing with you. That first part looks good. So I'm definitely seeing that you guys are understanding that fact, but there's a little confusion happening at the same time. Now let's see, how do we break down that denominator of AB 2 to the 3rd? So for this guy here, and I'm again going to do this a little bit on the side. So you've got A and B in parentheses and then the power of 2/3. So this is kind of what I call as the distribution rule for exponents, because that means both A and B have the same exponent of 2/3. So when you break this down, it will be A to the power of 2/3 and B to the power of 2/3. So yeah, like I said, think of it as the distribution rule, because this exponent of 2/3 has to go on A and B. So this is actually how we can start out by breaking down what's in that denominator part. So if I come back to my problem and rewrite this second part, I'm going to write this as A to the power of 2/3 and B to the power of 2/3. So I'm, starting out by just separating inside the parentheses itself. So you can see you're multiplying base A with base B. So again, if you're multiplying for here, we can again go back and use our product rule. But one thing we're going to have to be careful about is this minus sign over here, because minus sign, remember, always have to keep track of where those negative signs are going to be. So I'm actually going to leave this minus sign here, but I'm going to put a big bracket to kind of help us keep track of things. So using our product rule, your denominator portion of A and B is going to break down into log of A to the power of 2/3. And then remember, with product rule, we use a plus sign again, and log of B to the power of 2/3. Because product rule always uses a plus sign. So this plus sign, but then having this minus sign is going to affect the kind of signs you in. And that's one of the other common errors I saw happening in your answer. So have to be a little bit careful with that. And that's why I'm using those big brackets, so that we can keep track of how this AB is being separated. Now, of course, the first part of our problem is already solved. So we will just carry that forward. I'm going to leave the minus sign here and still keep using these brackets for now. So guys, at this point, all we have to do is separate that exponent of 2/3 from our bases A and B. So, for both of these here, you can basically, again, just use power rule and separate those exponents from the bases. So again, we'll have to individually use power rules on base A and base B. So this will end up, of course, bringing that exponent in front of its own logarithm. So you will now have 2/3 in the front, log of A for the first part. I'm still keeping that plus sign here. 2/3 in front of its own logarithm, and then log of B. And then the very final step that we have to do is distribute this negative sign. So this negative sign will go with the first logarithm inside the bracket and with the second logarithm inside the bracket. So that gives you, the first part again stays the same, log of 3 plus 2 times log of x. And now we have minus 2/3 log of a. And you know, some of you did have that minus sign there. The only difference was you did not distribute it to the second part, which was the minus 2/3 log of b here. So this is what our final answer comes out looking like. So you can see so Eileen, you did have the right setup. The only thing you had to be careful about were these two plus signs that you have on the second half. They actually needed to be minus, because remember guys, again, the idea is if we take this and work backwards, you know, so if we combine this into a single logarithm, it should go back to our original expression. And so that minus sign is crucial, because the minus sign tells us we will be using the quotient rule, and these will go in our denominator. So if you don't have that minus sign in there, it makes a difference. So you can see, Alice, you had the negative 2/3 on the log A, but you needed to distribute that negative sign to that log B also. So Cassie and I think one other student had the similar answer, Jackie, yeah. So just be careful, because what you guys did, at least that's what I am assuming, looking at that, it looks like you took your power of 2/3 and applied it to log of 3 and log of x. So is that what happened, Cassie, Jackie?
Yeah.
Yeah. So yeah, just be a little bit careful, because, you know, again, just those little tiny errors, as you can see, lead you to having something extra that shouldn't be in there. Emma, it looks like your first part definitely looks good. You can see you do not have the minus signs on the last two logarithms. And then your log of A, it looks like you left out that power of 2/3 because you just assumed the 2/3 went on B. But because we had both A and B in parentheses with the 2/3 outside, it applies to both our bases A and B. Haley, your answer looks good. You've got the minus signs for the last two logarithms, and you've distributed the 2/3 with both of them. That looks like Jess had already told you you had the right answer. So very nice keeping track of those signs and then working with those exponents. And then Katie, and I think Maggie, you were kind of on the same track over here. So Katie just needed to remember that exponent 2 was only on the x, not on the 3. So this would, not go in front of both 3 and x. And looks like Maggie, you also did the same thing. So just be careful with that. And then the second part, this is actually not wrong, but we just needed to simplify this further. And same thing, Maggie, over here, we just needed to break this down a little bit more. Tim, you ate up your log of 3 because I'm not seeing the
Yeah,
log.
I was getting rid of like terms. I thought the third 3 and the other 3 all canceled each other out. So that was where
Okay, got it. From the 2/3 power, yeah, because you don't have the 3 on the last two of your terms. Okay, got it. Because yeah, your 2 of log x looks good. Obviously, you brought the negative sign to both of those other terms, so that was keeping track of that. And then Megan, yeah, you did go ahead and bring that 2 in front of the 3, which we don't need here. So just that 2 in front of the log 3 was incorrect, but your 2 times log of x looks good. Minus 2/3 log of a looks good. And again, remember to distribute that negative sign to the negative 2/3 log of b. So that should have been a minus sign. So you guys can see, like, you have understood some part of it. You have been able to break it down to a certain point. And that's the reason why I picked this example, because, you can see we have used over and over again our product rule and power rule to try and break this down. We just did the quotient rule at the beginning to separate the numerator and the denominator, but then it takes a combination of those product and power rules to get it, to the final simplified state of these examples. So some of these examples are definitely a little bit more involved in terms of how you use these rules. And you will see, I've tried to include some examples here. So 15 and 16 are kind of where they're asking you to break it apart. But 17 and 18, they've already broken it apart. But now they're saying, oh, okay, we want to put it all together. So we actually want to combine this into a single logarithm. So we've got a couple minutes left over here. So let's do an example where we're taking something that's already been broken apart and we're trying to put it back together. So how about, this should not take us too long to work on it. You have 1/2 bracket. They're giving us log of x plus log of y. We're closing the bracket here. Then we have a minus sign log of z, and we're combining this into a single logarithm. So, of course, the bracket tells you those two are grouped together. That's why we have the bracket, the square bracket on the first part. Then you have minus log of z, and then of course the 1/2 in front of those brackets. So take a minute and I'll actually get our whiteboard set up here for this example.
Are you wanting us to show all of our work on this whiteboard or just the answers?
Just the answer, yeah. How do you have your final answer?
What's in the parentheses in the last log?
It should be z. I'm trying to see if I can erase it and rewrite it a little bit neatly. How do I remember this? So that should be z. So you should see a second page pop up for that. So again, you will be using multiple different rules, but in the reverse direction now to combine this into one single logarithm. Yes, I can see some of you already starting to write your answers out. I think you should be able to click on that link and it should take you, unless you have to switch your pages at the bottom or something like that. Alrighty, let's see who has a completed answer here. Okay, Maggie, looks like you have a completed answer. Okay, just a tiny bit of error. Again and again, think about the fact that X and Y are put inside a bracket and they have a 1/2 in front, because that's one of the common errors I'm seeing as you guys are writing out your answer. So Maggie and Tim, just a tiny bit of error in your answer. Megan, that looks good. Katie, that looks good. Jess, that looks good. Jackie, that looks good. Haley, that looks good. Dom looks good. All right, Alice, that looks good. Eileen, technically your answer is not incorrect, but I would probably combine the X and the Y together. I'm trying to see if I missed anybody. I think Katie already told your answer looks good. Really, very nice. Let's see, Emma, I can see you typing your answer in. That looks good. Angelica, you're typing your answer in as well. Okay, very quickly, guys. So the first thing, obviously, you can see is since you have a minus sign over here and there's log on either side, that of course tells us we are going to be using a quotient rule to, put that Z on the denominator. Obviously, you can see you have a plus sign between the log of X and log of Y, which means right over here, we will need to use a product rule. Additionally, you can see we have a number in front, which is being multiplied into this logarithm. So that actually tells us this will be coming from the power rule. So if you can identify, which different types of rules we will need, it will help you kind of combine the things together. So the first place I would start with is actually the product rule. I would go ahead and combine my log of X and log of Y into a single logarithm first. So go ahead and multiply those using the product rule. You get log of XY minus, log of Z. We'll keep that as it is. Then I would use the power rule to go ahead and consolidate our log of XY with that 1/2. So that would end up giving us log of XY. And remember, since the 1/2 is front of the entire log, which means the 1/2 actually goes on both X and Y. Because, some of you were writing it out as XY to the 1/2 without the parentheses. So if you don't put parentheses, that means the 1/2 is only going on Y, not the X. To show that it's going on both X and Y, you do need to put both of them in parentheses and then the 1/2 exponent outside of it, okay? And then of course we have log of Z over here. Now, some of you left your answer in this format where, of course, now we use the quotient rule to combine this together, which is where we end up getting log of xy on the numerator with 1/2, and then z on the denominator from that minus log of z. So I am seeing in your textbook, they are actually using that 1/2 to rewrite it into a square root. So they're rewriting this as square root of xy over z in the final answer. So I would say, if you see something like this in your homework, you can try both formats and see, will they accept if you just leave xy in parentheses with an exponent of 1/2, or do they want you to put it back into square root of xy? Because this is what your textbook is telling me we need to do. But I know sometimes in my math lab, they will accept if you leave it as xy to the power of 1/2. So yeah, basically, Dom, that's fine. Yeah, we're just finishing up. So basically the idea is you should be able to go in either direction, either looking at this example where we were breaking it down into, sums and differences of logarithms, or it's given to you as sum and differences and you're combining this into a single log. So we will stop right here, guys. We just have a little bit of section 4.3 to talk about, because this is where we're actually bringing in the base change formula that I want to talk about with you. And then in section 4.4, we literally have just 4 examples to look at to kind of show you how we bring in all these different rules and help us solve examples. So we'll probably finish the remaining part of that on Wednesday. If we have time, we'll start chapter 5, but we'll definitely finish chapter 4. And then let's hope my math lab is fixed sometime this afternoon, because it is still a little bit slow. But if you guys run into any more trouble with my math lab, please send me an email. So if there's something I need to do with technical support, I can talk to them about it. But it's out of our hands at this point. So yeah, just let me know if you have any concerns or any questions, okay? All right, guys, great job on those last 2 problems. I'm happy to see how you guys were kind of working through those, and then we'll pick it up on Wednesday. So be careful, everyone. Stay safe, and I will see you on Wednesday morning. Take care, guys. Be careful. Thank you. Thank you, guys. Have a great day.